This is the B-2 Spirit bomber, and without exaggeration, it remains the most capable stealth aircraft ever built. Its ability to strike any target on Earth grabs attention, but what stays hidden is the silent machinery behind every mission. Miss even one step, and this $2 billion aircraft becomes the most expensive lawn dart ever created. Everything begins inside the 509th Munitions Squadron's weapons assembly facility. This is not a warehouse. It is a controlled environment built for precision. Airmen prepare the weapons that will eventually sit inside the bomber's internal bays. And every parameter inside this building exists for one reason: stability. The temperature never changes. It stays locked at 68 degrees, not for comfort, but for physics. The ring laser gyros inside the guidance systems drift when temperatures fluctuate. Even a few degrees can introduce errors that cascade into missed targets hundreds of miles away. The first step is attaching the MAU-169 guidance section to the front of the weapon. Inside it sits a GPS antenna no larger than a hockey puck. Beneath that, an inertial measurement unit sensitive enough to detect motion smaller than the width of a human hair. Targeting data flows through the control module, but the most critical component is the umbilical connector. This is how the bomber communicates with the weapon before release. If this link fails, the bomb becomes inert, precise, expensive, and completely useless. Technicians secure the guidance section using calibrated torquey wrenches. Too loose, and vibration will destroy alignment during flight. Too tight, and the housing cracks. There is no margin here. Precision isn't encouraged, it's enforced. Next comes the tail kit. This assembly holds the control fins, each driven by electric actuators capable of adjusting position in increments of 1/10 of a degree. These aren't simple metal flaps. They are precision control surfaces that decide whether a weapon hits or misses. Before the weapon ever leaves the building, technicians cycle the actuators through program movements. They're watching for binding, hesitation, or delay. A fin that sticks for half a second can shift impact by over 100 feet. The completed weapon is then weighed. Exact mass matters. The B-2's mission computer relies on precise ballistic calculations, and a difference of just 5 pounds alters timing, trajectory, and release parameters. Throughout this entire process, the weapon remains completely safe. The fuse is unpowered. The guidance system is in test mode. The thermal battery that enables detonation will not activate until it experiences the violent G-forces of release. Until then, it is nothing more than a highly sophisticated piece of metal. Once each weapon passes inspection, it's logged into the weapon's database and moved onto specialized transport trailers. These aren't standard carts. They maintain the same controlled environment as the assembly facility because even a short exposure to cold or humidity can affect the guidance systems. But the weapons don't get loaded yet, not until the aircraft itself is cleared. And preparing a B-2 for combat is an entirely different level of obsession. Unlike the bombs, which must be mechanically perfect, the bomber has to be electromagnetically perfect. Out on the flight line, low observable technicians face their greatest enemy, physics. The B-2's stealth isn't invisible magic. It's the precise manipulation of electromagnetic energy, and it only works if the aircraft's surface is flawless. The bomber isn't painted like a conventional aircraft. It's covered in radar-absorbent material designed to convert incoming radar energy into heat. This coating contains microscopic iron particles that vibrate when struck by radar waves, neutralizing detection. The problem is durability. That material is fragile. Heavy rain, hail, bird strikes, any of it can damage the surface. And damage means reflection. Reflection means detection, which is why technicians inspect every inch of the aircraft before anything else happens. Welcome to Jet Vision. This is where classified programs, silent aircraft, and real military capability come into focus. Here, we don't deal in rumors. We break down what's flying, what's funded, and what's already shaping the future of air dominance. Before we begin, understand this. 98% of the people watching Jet Vision aren't subscribed. If you support American military innovation, if you respect the men and women who design, build, and fly these machines, hit subscribe, like this video, and drop a salute in the comments to show your support. Technicians move slowly across the airframe, scanning for chips, bubbles, scratches, or rough patches. Leading edges receive the most attention. This is where radar energy strikes first, and even microscopic imperfections can compromise the aircraft's signature. Engine inlets are inspected next. Any irregularity here creates what engineers call a radar scatterer, a tiny flaw that acts like a beacon, reflecting energy straight back to enemy sensors. Panel seams are just as critical. Each seam is sealed with conductive tape that must be perfectly smooth. A gap the width of a credit card is enough to raise the radar signature beyond acceptable limits. When problems are found, and they always are, the repair process begins immediately. Damaged areas are sanded using precision tools. Too aggressive, and you create new reflections. Too gentle, and the repair won't bond. Technicians mix radar-absorbent compounds with working times measured in minutes, not hours. Curing must occur at exact temperatures. Too hot, and the material bubbles. Too cold, and it fails to adhere. Once cured, surfaces are sanded flush to tolerances measured in thousandths of an inch. Over any foot-long span, variation cannot exceed the thickness of a few sheets of paper. This is why B2 maintenance takes so long. You're not repairing an airplane. You're sculpting it. Every contour, every edge, every surface exists to control how the aircraft interacts with energy you can't see. While low observable specialists work, other maintainers inspect the mechanical systems. The B2's hydraulics operate at pressures high enough to cut through steel. Redundancy is built in, but only if every system performs exactly as designed. 4 independent hydraulic systems provide backup. Lose one, operations continue. Lose 2, the aircraft can still fly. Lose 3, you can land, but not comfortably. On a tailless aircraft, control authority is unforgiving. Flight control actuators are checked for even slight sluggishness. Landing gear, brakes, tires, environmental controls, and electrical buses are inspected in sequence. If any system fails, weapons loading stops immediately. The aircraft must be flawless before a single bomb goes near it. Only after every checklist is signed off do weapons crews move the JDAMs beneath the bomber, positioning them carefully below the internal bays. Each JDAM is positioned on a hydraulic lift designed to raise the weapon into the aircraft's internal bay. Unlike other bombers, the B-2 carries nothing externally. Any external store would destroy its stealth profile. Inside or nothing. The weapons bay doors are massive, each weighing as much as an SUV. They open on hinges that must remain perfectly aligned. Even slight misalignment creates radar reflections large enough to compromise the aircraft during a mission. Inside the bay sits the rotary launcher. Think of it as a revolver cylinder scaled to hold bombs. 8 positions, each capable of supporting a 2,000-pound weapon. The entire assembly can rotate a full 360 degrees in under 3 seconds. That rotation doesn't sound dramatic until you remember it's spinning nearly 8 tons of explosives, fast enough to shift the aircraft's center of gravity. The flight control computers compensate instantly to maintain stability. Each weapon mounts to suspension hooks rated for forces far beyond the bomb's weight. During combat maneuvers, G-forces multiply mass. A 2G turn doubles effective weight, which is why those hooks are engineered with extreme margins. The mechanical interface between weapon and aircraft must align perfectly. Misalignment by the width of a penny and the weapon won't receive power or data. The lugs lock into place, securing both the bomb and the communication pathway. Inside those connections run the cables that link the JDAM to the aircraft's stores management system. This link is critical. Without it, the bomb never receives targeting information and would fall like an unguided weapon, missing by miles. But even now, the bomb doesn't know its target. Coordinates are not loaded on the ground. That data stays inside the bomber's mission computer until seconds before release, allowing targets to change mid-flight as battlefield conditions evolve. Even fully loaded, the weapons remain inert. Fuses stay unpowered. Guidance systems remain dormant. Only basic communication and diagnostic functions operate. The philosophy is simple. Keep the weapon as dumb as possible until the last possible moment. Once loading is complete, attention shifts to the crew. Because no matter how advanced the aircraft is, the mission still depends on the humans inside it. And keeping them alive requires preparation just as obsessive. Inside the 509th Operational Support Squadron's Aircrew Flight Equipment Shop, specialists prepare the gear that keeps B-2 pilots alive. The aircraft flies high enough that a sudden loss of cabin pressure would be fatal without immediate protection. The B-2's operational ceiling is classified, but it's high enough that pilots require pressure suits, not just oxygen masks. These systems must function perfectly while the crew is pulling Gs, and breathing feels like fighting against gravity itself. Masts are connected to pressure rigs that simulate extreme altitude conditions. Oxygen flow, seal integrity, and pressure response are verified repeatedly. Communication systems are tested at the same time. In an emergency, there is no opportunity to troubleshoot. The helmet alone costs more than most homes. It isn't just protection, it integrates heads-up displays, night vision compatibility, and flash protection capable of blocking the light from a nuclear detonation in milliseconds. Survival vests are inspected next. Emergency beacons, signal mirrors, water purification systems. Everything designed for the possibility that a B-2 crew could eject over hostile territory. Nothing is optional. Nothing is overlooked. The anti-G suits receive special attention. Their inflatable bladders must hold exact pressures. Too little pressure, and the pilots black out during maneuvers. Too much and breathing becomes restricted at the worst possible moment. Each suit is custom fitted. What works for a 6'2" pilot won't work for someone 5'8". In an aircraft where missions can last over 40 hours with air refueling, comfort isn't a luxury. It's a requirement for survival. With crew equipment cleared, the ground teams prepare for one of the most dangerous procedures in Air Force maintenance: hot pit refueling. Unlike standard refueling, the engines stay running. The B-2's 4 engines idle at temperatures capable of melting aluminum. This procedure exists for rapid turnarounds when there's no time for shutdown and restart. Every second saved matters. Fuel crews approach wearing silver proximity suits that resemble astronaut gear. These suits allow only brief exposure to extreme heat, just enough time to react if something goes catastrophically wrong. Each crew member carries a fire bottle capable of projecting suppressant foam over 30 feet. Communication is limited to hand signals. The engines produce a constant roar, loud enough to drown out radios and strip away any margin for error. The first step is grounding the aircraft. After flight, the B-2 carries thousands of volts of static electricity. One spark near fuel vapors would be catastrophic. A grounding cable as thick as a garden hose clamps to bare metal on the landing gear. High-flow hoses connect to the single-point refueling port. Fuel moves fast, up to 600 gallons per minute. In less than 30 minutes, the bomber can take on over 160,000 pounds of JP-8. But quantity isn't enough. Fuel distribution matters. Too much forward and the aircraft becomes nose-heavy. Too much aft and it destabilizes. With no tail to provide balance, weight management is everything. Temperature matters too. Fuel that's too cold won't flow correctly. Too hot and vapor bubbles form, risking engine flameout. Crews monitor pressure, flow rate, and temperature constantly while the engines thunder just feet away. When refueling is complete, the B-2 is finally loaded, fueled, stealth certified, and ready for its crew. Only then do the pilots approach the aircraft, climbing through a hatch behind the nose gear and up a narrow ladder into the cockpit. Now here's the reality. 98% of the people watching this video are not subscribed. That means most viewers see the intelligence, but don't stay connected. If you support American air power, if you respect the engineers, maintainers, and pilots who hold the line, like this video, subscribe to Jet Vision, and drop salute in the comments to show you stand with them. Everything covered here is built in silence, tested in secrecy, and revealed only when it's already changed the balance of power. This channel exists to cut through noise, politics, and speculation, and deliver what actually matters. They strap into ejection seats that cost more than most college educations. These aren't chairs. They are survival systems, capable of firing the crew clear of the aircraft in less than a second, even at zero altitude or inverted. Oxygen lines connect. Intercom cables lock in. The cockpit comes alive as displays illuminate. The B-2 is fully digital. No analog gauges, no margin for improvisation. Initialization begins with the inertial navigation system. For 8 minutes, the aircraft cannot move. not even an inch. Ring laser gyros measure the Earth's rotation to establish a reference frame. Interrupt the process and it starts over. Encrypted military GPS loads next, far more precise than civilian signals. Accuracy measured in feet, not yards. From this moment on, every movement of the aircraft is tracked, calculated, and verified. As the aircraft begins to taxi, the pilots run full control surface checks. The B-2 has no tail, no vertical stabilizers, no conventional rudder. Yaw control comes from split drag rudders at the wingtips. These surfaces open asymmetrically like air brakes, creating controlled drag to induce turns. If even one fails, coordinated flight becomes impossible. Every movement is confirmed by multiple redundant sensors. The elevons sweep through their full range. Up, down, differential movement for roll. On a flying wing, a single malfunction isn't an inconvenience. It's a mission-ending event. Taxiing itself is a calculated maneuver. The nose wheel sits more than 100 feet ahead of the main landing gear. Every turn must be planned seconds in advance, or the aircraft will depart the pavement. It's like driving a semi-truck in reverse, except the vehicle weighs over 300,000 pounds and costs $2 billion. One mistake here doesn't dent metal, it ends the mission. Before takeoff, the crew briefs abort points, engine failure procedures, and rotation speeds. At maximum weight, the B-2 uses nearly the entire runway. There is no excess margin. Once past rotation speed, the aircraft is committed. Abort is no longer an option. Throttles advance to military power as 4 engines spool, each delivering controlled thrust without afterburners. Acceleration presses the crew back as nearly 70,000 pounds of thrust fight hundreds of thousands of pounds of aircraft mass. The nose wheel lifts first. The wing follows only when physics allows it. At altitude, the B-2 enters air so thin, the engines produce a fraction of their sea level power. Stability is no longer aerodynamic, it is mathematical. Flight control computers make over 1,000 corrections per second. Without them, the aircraft would depart controlled flight almost immediately. The B-2 doesn't fly itself, it is flown by equations. As the bomber approaches the target area, the crew transitions from navigation to weapons management. Displays shift, priorities change. Every system now exists for one purpose. Inside the weapons bay, the rotary launcher begins to index. 8 positions rotate smoothly, aligning the selected JDAM with the release point while the bay doors remain sealed. Opening those doors too early would spike the radar signature instantly. Timing is everything. The aircraft stays silent, invisible, waiting for the precise release window. When the moment arrives, the doors open for seconds, not moments. Airflow disrupts the aircraft. The flight computers compensate before the crew can feel the change. Only then does the weapon wake up. Through the umbilical connection, the mission computer floods the JDAM with data measured in decimals and milliseconds. Coordinates load to extreme precision, wind vectors at multiple altitudes, barometric pressure, planned impact angle, time to target. The weapon processes it all in fractions of a second. Internal diagnostics run instantly. GPS receiver acquiring satellites. Inertial system aligned. Control fins verified. Thermal battery standing by, still inert, still safe. Release happens between heartbeats. Suspension hooks disengage. Pneumatic ejectors push the bomb clear of the bay at exactly the speed required for stability. The JDAM separates cleanly, falling just fast enough to clear the aircraft, slow enough to remain controlled. The umbilical snaps free. That is the moment everything changes. The thermal battery ignites. Power floods the weapon. The fuse arms. Tail fins unlock and deploy as the bomb transitions from inert mass to guided weapon. The GPS receiver locks onto satellites. 4, then 6, then 8. Accuracy tightens with every signal as the weapon refines its position in 3-dimensional space. Inside the JDAM, the onboard computer runs continuous calculations. It knows where it is. It knows where it must go. It plots a curved flight path that accounts for wind, air density, and Earth's rotation. 2 seconds after release, the fins make their first correction, a subtle adjustment, barely visible, compensating for crosswinds detected earlier by the aircraft's sensors. The weapon doesn't fly, it falls with intent. Each fin movement trades altitude for lateral correction, walking the impact point closer with every passing second. If GPS is jammed, the inertial system takes over immediately. Accuracy drops, but control remains. 30 meters instead of 10, still lethal, still precise. As the weapon descends, corrections become smaller and more frequent. In the final 10 seconds, the fins adjust hundreds of times, movements so subtle they resemble vibration. The radar altimeter activates, measuring precise height above ground. The weapon now knows exactly how much time remains before impact. The margin for error shrinks to feet. The final correction occurs fractions of a second before impact, a microscopic adjustment that shifts the strike point just enough to ensure mission success. Then it hits. The JDAM delivers its payload exactly where commanded, long after the B-2 has disappeared back into the night, unseen and unchallenged. For the crew, the mission isn't over. They turn away silently, systems already recalculating fuel, routing, and threat envelopes for the journey home. Behind them, the strike unfolds exactly as planned. No warning, no radar track, no chance to react. That is the true power of stealth executed correctly. Every successful mission reinforces the reality that the B-2 is not just an aircraft. It is a system of systems where precision maintenance is as critical as precision weapons. Thousands of hours of preparation lead to seconds of execution. Miss one step on the ground, and none of this works in the air. That is why the B-2 remains one of the most maintenance-intensive platforms ever built. Not because it's fragile, but because perfection is the requirement. The bomber returns to base as silently as it departed, carrying no evidence of what it just accomplished. Only data, logged and analyzed for the next mission. Once the aircraft is shut down, the cycle begins again. Data is pulled. Systems are reviewed. Every anomaly, no matter how small, is documented and investigated. Low observable technicians return to the surface, searching for anything that may have changed during flight. Heat, moisture, and airflow all leave signatures that must be corrected. Weapons crews account for every serial number, every data log, every connection that mattered in the strike. Nothing leaves undocumented. Nothing is assumed. This is the invisible side of air power. No flyovers, no footage, just relentless discipline that turns engineering into dominance. And that's why the B-2 remains unmatched. Not because of what it drops, but because of everything that happens before it ever leaves the ground. Every mission proves the same truth. Stealth isn't a feature you turn on. It's a discipline you maintain hour by hour, inch by inch, before the aircraft ever moves. The B-2 Spirit doesn't rely on speed or firepower alone. It relies on preparation so exact that failure is engineered out long before the engines ever start. This is why only a handful of nations can even attempt to build aircraft like this. It's not about money. It's about precision, patience, and an industrial culture that tolerates no shortcuts. When the B-2 flies, it carries more than weapons. It carries the work of thousands of specialists whose names will never appear in headlines, but whose precision decides outcomes. And that is the real secret of America's stealth bombers. Not invisibility, but discipline. The kind that turns preparation into power and silence into victory. What you just watched isn't speculation. It's the reality of modern air power. Built in silence, tested in secrecy, and revealed only when it's already too late to counter. This is why air superiority still matters. This is why preparation beats reaction. And this is why the future of warfare is decided long before the first shot is fired. If you value American military strength, if you stand behind the engineers, maintainers, and pilots who keep this edge alive, leave a salute in the comments, like the video, and subscribe to Jet Vision. This is Jet Vision. Stay sharp, stay proud.